So here's our proof. First of all, looking at this question, I've got tan, I've got secant. This is probably one, if I'm going to prove it, that I should change things to sine and cos, because I can't directly change tan to secant or secant to tan. So I'm going to change things to sine and cos. Now the first thing you're going to wonder about is, what do I do with tan squared? Well, what does something squared mean? Tan squared means tan theta times by tan theta. And if tan theta is sine over cos, then tan theta times tan theta would be sine over cos times sine over cos. And so when we have tan squared theta, it makes sense that that's sine squared theta over cos squared theta plus 1. And when I have secant squared theta, since secant is 1 over cos, secant squared would be 1 over cos squared. So the main strategy we've had for proofs up till now with changing to sine and cos is, after you change to sine and cos, see if you can write both sides as a single fraction. The right side, already a single fraction. No problem there. The left side, well, I have two things. If I want a single fraction, I have to add fractions. I need a common denominator, so I'll multiply this 1 by cos squared over cos squared to get that common denominator. And I get sine squared plus cos squared all over cos squared. I now have the left side as a single fraction as well, but they're not the same. So now I have to look, is there anything else I could do? Well, looking across, my denominators are the same. I have cos squared on one side, cos squared on the other side, so that's good. But my numerators are different. What do we know about sine squared plus cos squared? It equals 1. So you're allowed to use that and just say, oh, I know that that's equal to 1, so I'll change it to 1, and now I'm done. And we've proven it. Woo! So similarly, you could prove the other one, but you'll never be asked to prove these ones because they're on your formula sheet, and from this point forward, you can just use them like a known fact. We now know that tan squared theta plus 1 is secant squared theta, and we can use that whenever we want in any proof. And these are called our Pythagorean identities. And with these Pythagorean identities, you can use them, and you can use any form of one as long as it's just one operation. So for example, sine squared plus cos squared equals 1. We've already used that and other forms. So if you know sine squared plus 1 equals cos squared, you know that sine squared is 1 minus cos squared. That's just moving cos squared over to the other side of the equation. You know that cos squared is 1 minus sine squared. So if you can just do one operation to any of your identities, you can use those directly in a proof without showing your work. Anytime you do 2 or more operations in your head, you have to show that work on your proof, right? You can't just, and I've seen this on an exam. There was a hard proof, and the student wrote on their final exam, "Ladies and gentlemen, it is obvious that this equals this. No work need to be shown. Proof complete." Yeah. They got 0, but it was very nice and made us laugh. You can't just say, oh, prove. Yes, it's true. Good. Done. Thank you. Give me the free marks. Yeah. For all my questions, I know the answer to this one. Please challenge me more. I'm going to leave it blank. That's not going to get you the marks. So, but you're allowed to use one shift of it. So we have tan squared plus 1 equals secant squared. So if you have a tan squared in your equation, you could move the 1 over and change it to secant squared minus 1. Or if you have a 1 in your equation, you could move the tan squared over and say, I'm going to change my 1 to secant squared minus tan squared. You could do that. And same thing with cotangent and cosecant squared. So what we have now are proofs, and I've listed a third one here. You can write that one down as well. Your job for tomorrow is to have your own proof, bring it to class on a scrap piece of paper. If you want to grab a scrap piece of paper, some now. Do each of these 3 proofs and have them ready for tomorrow. You can start working on them now. Maybe you finish all 3 before the end of class. What these 3 proofs will do is they will have your Pythagorean identities in them somewhere. Sometimes changing to sine and cos is going to be your best strategy. Sometimes changing to sine and cos is going to make your proof longer and won't be the best strategy. So now that you have these new identities, you're going to have to start making decisions. When should I use 1? When should I change to sine and cos? And how is that going to look?